We're going to talk about top today. One main use of top in Linux is when you have a very busy system. Then you want to know what's going on, like your laptop when it's spinning, when the fan is giving out a lot of noise and it's very hot. And what you want to do is you go to top and you could see like which process is running depending on the sorting order. Like in this case it's the CPU time. The process that takes the most CPU, that would be on top. I have a test process here which is like A1, which is on, because it's multitasking, so some of the tasks are ranking up and down depending on who is taking more CPU time. On the screen you could also see your load average, which is here. I normally would, like, depending on how many CPU, if it's like 4 CPU, then divide by 4, like this one, 4 divided by 4 is 1, so it's like one process is running at the same time at this moment. If you have like 4 CPU with 16, that means 4 processes running at a time, which is heavy load. You could also see I have 32 GB memory here. Total, how much memory is free and how much is used. The used figure is a little tricky because in Unix or Linux in general, it uses memory for buffer cache also, and also for virtual memory management. So that's why you might see more used memory. But doesn't mean that is using up all your RAM. You have swap space. Normally your swap should be not used. It's a very memory tight system where you see process swapping. When I troubleshoot, I don't really want to see swapping going on for higher performance or average performance system. You can see how many tasks are running, total, and how many are running, how many are sleeping, so on. This is the PID. Now you could press 1, the key 1, to see the number of CPUs on your system and the processes, the CPU time spent on each type of stage of your processes. The US means user space, SY means system space, your nice priority, which is the higher the number, the lower priority that you have, idle process, swap out process, so on. Let me go back to, when you press 1 again, the toggle back. Right, now say if I see a process is taking up much of my CPU time, and this case is this one here, just keep looping and printing hello. What I want to kill it, so I could kill it from another terminal, or I could kill it here. So press the key and it asks for the PID, and in this case is here 24235, and enter, and it asks you if you want to send this PID, this process, the signal 15, which is normally SIG terminate signal. So I set 15, and you can see that is terminate here. Alright, so it's killed. Again, you could do the same thing in another terminal. It's the same thing, doesn't matter. You could also sort the output. I usually would see how much memory, which process takes up most of my memory. So I press the big M, uppercase M. Then I would be able to sort by like Kden Live is running another screen which has which is using most of 12% of my memory. And if I want to toggle back to sort by process priority, could say P, which is big P, which is percent of CPU used. So I'm seeing my FFmpeg pack is using most of my CPU time, because right now I'm doing screen recording, and that means it's heavily using my CPU. It's an old system, so probably it's not using a good GPU, so it's just purely using CPU time. When you want to use a different view of the top process, you could press M, which is a small M, which will show toggle around like 4 different way of looking at your the screen, the top screen, which is not normally very useful. I usually just stay with the default one, and that basically is it. So to summarize, when you want to troubleshoot why the system is so busy, the first thing is you go to top, you look at your overall system performance. You want to see your low average is depending on the CPU, number of cores of the CPU. If you have like 4 cores, then might be around 4 to 6 will be fine, or light low. If it's shooting up to a high low average, then that's one of the reasons that you want to look at the CPU percentage, like down there, which one is using most of the CPU. Particularly when you look at memory also, you will press big M. You look at these 3 memory figures here. Virtual memory is of course the amount of total virtual memory that this process claims. You also have resident memory. RES is resident. Resident meaning it's like a working set. It's the amount of memory that process resides in memory most of the time. So that's a good indication of how much RAM the system is actually spending on. It is the most efficient area where a process stays in RAM. And share is the amount of share libraries it's using that would be, let me switch off that would be using to be shared with other processes. So the more shared memory, the more efficient your system is using RAM. The resonance set is a balanced figure. I would love to see that a process stay in RAM with a proper resonance set, that your RAM size would be comfortably to accommodate it. So obviously, if it runs in RAM, it's always better, faster, without swapping, without swap in and out, and so on. And if it maintains a fairly good resonance set, that's good. If it keeps expanding, the resonance set keeps increasing, it probably is a memory leak problem, or your problem domain of that process is not is increasing load. And of course, the total amount of virtual memory indicates how big that program requires in terms of system resources. So that basically is it. Then if you see there are processors that are hogging your CPU, which is not necessarily like that, then obviously you kill it. And that's it. So thank you for watching.